Hey everyone, and welcome. So today we're going to dive into something that's honestly just critical for any modern application: resilience. We're going to talk about how to build systems that don't just, survive failures, but actually handle them gracefully. So let's get into it.
You know the feeling, right? We've all been there. You're on an app, you click something, and nothing. Everything just freezes. You hit refresh, still nothing. So what's really going on behind the scenes? Well, what started as this tiny hiccup somewhere has just dominoed into a full-blown outage. But why does that happen? Let's break it down. All right, so let's use a super common setup as our example for today. You've got your front end, that's what you, the user, are looking at. That front end needs to talk to a back end to get its data. And that back end, well, it relies on some external third-party API. And look, when everything is green, life is good. It's the happy path. The user gets what they want and they get it fast.
But then, disaster strikes. That external API, it's having a really bad day. It's not totally down, but it's gotten super slow, super unreliable. So what's the domino effect here? Well, the backend starts sending requests to that slow API, and those requests just hang. They start timing out, and that ties up all of the backend's resources. Pretty soon, the backend itself becomes completely unresponsive. And of course, that means the front end is just stuck, spinning its wheels, waiting for a response that is never ever going to come. And the end result for the user? A total system meltdown, all because of one flaky component.
Okay, so how did we used to try and fix this stuff? Well, the old way, the in-code way, was basically to make every single developer responsible for it. They'd have to write all this resilience logic, retries, timeouts, all that jazz, directly into their application code. And as you can probably guess, this gets real messy real fast.
Yeah, this approach has some major pain points. I mean, think about it. When every team is rolling their own solution, you just get chaos. The front-end team might implement 3 retries, but the payments team does 5. It's totally inconsistent. Then you've got all these different language-specific libraries, which just bloats every single service with tons of boilerplate code. But honestly, the worst part? If you decide you need to change your retry policy from 3 to 2, you have to go back and update, retest, and redeploy every single service. It's just not scalable. It's incredibly brittle.
But thankfully, there is a much better way. And that's where the service mesh comes in. This is really the modern solution to this whole problem. Think of it as a dedicated safety net that sits under your entire application.
I absolutely love this analogy because it just hits the nail on the head. See, a service mesh isn't part of your application code. It sits right alongside it at the network layer, and it manages all the traffic flowing between your services. And the beautiful thing is, it doesn't care what language your services are written in, Go, Python, Java, whatever. It just sees the network traffic and applies a consistent set of rules to it. It's like having an expert traffic controller for your whole app.
Okay, so let's go back to that comparison chart. This is the big reveal, and it really shows you the power of the mesh. Remember all those problems we had on the left? Well, the service mesh just solves them, all of them. Instead of that inconsistent chaos, you get one centralized, consistent policy for every single service. Because it's at the network level, it's completely language agnostic. Your developers get to stop writing boilerplate and focus on building features, because you don't have to change any application code. And the best part? If you need to tune your resilience strategy, you do it in one place and it applies everywhere instantly. It's a game changer.
Okay, that all sounds great in theory, right? But how does a service mesh actually do all this stuff? Well, it comes with this amazing toolkit of resilience patterns. Let's break down the big 3.
All right, first up we've got timeouts. This is really your first line of defense. A timeout is super simple. It just sets a rule that says, hey, I am not going to wait for a response for more than, say, 200 milliseconds. And this is absolutely crucial. It stops one slow service from tying up all your resources and causing that cascading failure we saw before. And from a user's perspective, trust me, a fast error message is always better than a screen that's just frozen and unresponsive.
Okay, next up in the toolkit, retries. Sometimes things just fail for a second. A network hiccup, a temporary glitch. A retry it tries the failed request again. But the key here is that the service mesh does this smartly. This isn't just a dumb loop. You can configure it to only retry on certain kinds of errors, like a 503 service unavailable, and, really important, to only try a limited number of times. The last thing you want to do is accidentally launch a denial of service attack on your own struggling service, right?
And finally, we have the ultimate safety valve, the circuit breaker. It works exactly like the circuit breaker in your house. If an appliance keeps shorting out, the breaker trips to protect the rest of the house. Same idea here.
If a service fails too many times in a row, the mesh just trips the breaker. What that means is it immediately stops sending any more traffic to that failing service for a little while. And this does two amazing things at once. First, it protects the rest of your system from that failure, and second, it actually gives the broken service a break, a chance to recover, without getting hammered by even more requests.
Okay, so let's rewind. Let's replay that original failure scenario. But this time, our app has the service mesh safety net. Step 1, the external API starts to get slow. The mesh sees this immediately and enforces our timeout, cutting off that slow request. No waiting around. Step 2, it attempts one smart retry, just in case it was a fluke. Nope, that fails too. So after a few of these failures in a row, bam, the circuit breaker trips. And for the next 30 seconds, it just stops all traffic to that faulty API. Period.
So what's the result? This is the most important part. Look what didn't happen. Our backend service never got bogged down. The front end never froze. That whole failure was completely contained by the mesh. So instead of a total meltdown, what does the user see? They get a fast, clean error message. Something like, hey, some data is unavailable right now, please try again in a moment. The core of the application is still up, it's still responsive. And that is a huge win.
Okay, so you're sold. How do you actually put this into practice? Let's wrap this up with a really actionable playbook. This is a fantastic starting point if you're using something like Google Kubernetes Engine. But wait, before I show you the list, I have to say this, and it is the most important takeaway of this entire explainer. Do not use the defaults, ever. Resilience is not a one-size-fits-all thing. You absolutely have to tune these settings based on your app's real traffic and, even more importantly, your service level objectives, your SLOs. What level of performance have you actually promised your users? That question should guide every single one of these settings.
So with that in mind, here are 5 key configs you can standardize on to build your playbook. You start with the basics we've already covered, right? Sensible default timeouts and limited retries, but only for actions that are safe to repeat. We call that idempotent. Then you get a little more advanced. Aggressive circuit breaking to isolate problems fast, and something called outlier detection, which can proactively eject unhealthy services from the pool. And finally, you got to manage your resources with connection pooling limits. This stops any one service from overwhelming another. You put these 5 things together, and you have a seriously powerful resilience strategy.
So I'll just leave you with this final thought. When you offload all of this complex, tedious, but critical resilience work from your developers and give it to the mesh, you free up so much of their time and brain power. So the real question is, if your network can handle failures automatically for you, what incredible new features, what amazing innovations can your developers focus on building instead? Thanks for joining me.